Hey there students, today we're continuing our work with right-angled triangles by moving on to trigonometry. We're going to start off with the tangent ratio today, both to find the lengths of sides and to find the sides of angles as well, and then we'll move on to the other ratios and applications next week. Okay, first thing we're going to do, I'd like you to give yourselves the subheading labeling first, because before we figure out how to use the ratios themselves, we're going to have to, we need to know what side is which in the right angle triangle. Okay, so follow along with me. I'm going to draw myself a nice big right angle triangle just here. And these are the same examples, by the way, as what's in the PowerPoint that was shared to connect. This is just explaining it in a little bit more detail. Okay, so like what we did with Pythagoras earlier in the week, the hypotenuse is the longest side in the right angle triangle, and it's opposite the right angle as well. So we're going to label that one first. What I'm going to add though this time is an angle here. Now that little symbol there is called theta. It looks a bit like a zero with a belt around it or something like that. Theta is just a Greek symbol that we commonly use to refer to angles. So when you see that written in a right angle triangle like that, it just means that's the angle that we're either going to find or the angle that we're looking for or whatever. So I'm going to label that as the angle. Okay. Now the reason it's important to point out where the angle actually is that it changes the name of the other two sides in the right angle triangle. So the side that is opposite the angle, so that the given angle or the angle that we're trying to find, we imaginatively call the opposite. And the other side, so the one that's on the bottom in this triangle, we call that one the adjacent, because adjacent is a word that means next to. It's the side that's next to the given angle. Okay, so don't forget those two, I'll highlight them. The opposite and the adjacent, we name those according to where the given angle is, or the angle that we're looking for. Okay, so with that out of the way, we can give ourselves the subheading tangent ratio. And you might just refer to it as 10, that's your decision. So I'll get you to write this ratio down with me as well. So tangent, or 10 for short, of whatever the angle is equal to the length of the opposite side divided by the length of the adjacent. So what does that actually mean? So because it's a ratio, it's telling us that for a particular angle, and whatever that angle might happen to be, it tells us what the value will be if we take the length of the opposite and divide it by the length of the adjacent. So if we've got a triangle like this, so say we've got an angle of 60 degrees, it's a right angle triangle, this side would then be the opposite, this side over here would be the adjacent. So what that ratio tells you, if I was to plug in tan 60 into my calculator, so like tangent ratio for 60 degrees, that'll give me a value of 1.73. So if I link that back to the ratio that we just started with, all that tells me, losing my paper, all that tells me is if I take the length of the opposite in that triangle and divide it by the length of the adjacent, it's going to give me a value of 1.73, and that'll be a different value depending on what angle that you've chosen, but in this case for 60 degrees it'll be 1.73. I'm going to just add in there to 2 decimal places because it's pretty sure it's an irrational number. Okay, so that begs the question how we actually use the tangent ratio rather. See, I fall into that trap myself as well. What I'll get you to do, follow along with me as I draw this triangle. I'm going to say my angle's 30 degrees. The length of the adjacent side is 5 meters. And I'm going to say we want to find the length of this side here, which is A. So because we've got one unknown there, and we can use our tangent ratio to solve for the thing that we don't know. So what I'll get you to do is also write down the steps that we'll use to solve this problem. So kind of like when we did Pythagoras, we're going to label the triangle to begin with. We're going to write the ratio down, as in tan of the angle equals opposite over adjacent. Then we're going to substitute the values that are given in the question, and then we'll answer the question by solving for whatever the unknown thing actually is. Okay, so for this question that we've been given here, so I'll start by labeling the sides. We've got, and hypotenuse we don't use for the tangent ratio, but that will come up later when we do sine and cosine. The length that we don't know is the opposite, because it's opposite the angle, and the length of the adjacent side is 5 meters. So there's 2 bits of information we've been given. So if I start by writing out my equation, so tan of the angle is opposite over adjacent. So that's steps 1 and 2. Step 3 is to fill in what we know from the diagram. So tan of the angle, tangent of the angle, so 30 degrees. So tan of 30 is equal to the length of the opposite, which we don't know, that's given as A in the diagram, divided by the length of the adjacent. Okay, so the last step for this one is to solve. So when you've got something like this, just bear in mind with your what you might remember from solving equations, we want to get this value for A on its own, but it's currently being divided by 5. So to cancel that off, we would need to multiply that by 5 to cancel here and here. But because we've got an equal sign in the middle, we need to do everything that we do to one side of the equation, we have to do to the other side as well. So on the other side, we're going to have to do tan 30 multiplied by 5. Now those steps you might not necessarily write in, you might just jump into the next part by saying A is equal to tan 30 multiplied by 5. That's totally fine, but if you want to show you full working, it'll take you longer. I'd get into the habit of just rearranging it like this, but that at least shows you where it actually comes from. Okay, so now our answer for this one to 2 decimal places, if I refer to my working from earlier, is 2.89 meters to 2 decimal places. Okay, so what we've done now is that we've used trigonometry, so the tangent ratio in this example, to find the length of this missing side A just here. And that's it. We'll do a couple of other examples as well. Or actually, we'll do one more to begin with where we find the length of the adjacent. So again, let's draw another right angle triangle just here. Okay, so this triangle, I'm going to say my given angle is 40 degrees and is here. I'm going to say that the length of the adjacent is something that we don't know, and the length of the opposite is 15 meters. I've got my colors the wrong way around, so I'll just do, I'll commit to it being opposite world and do black. Okay, so B is the adjacent, and 15, that side is the opposite. Okay, so I've labeled my diagram. Next step is to write the ratio down. Tangent of the angle equals opposite over adjacent. Now I'm going to fill in what I know from the diagram. So tan of 40 is equal to the length of the opposite, which is 15, divided by the length of the adjacent, which is B. Okay, so this is where this one gets a little bit more tricky, because the length of the side that we're looking for, so B, this is now on the denominator of this equation, which makes it a little harder to rearrange. If you were doing this the long way, we could do a bit of like a cross, not so much a cross, actually no, we'll do more of a cross multiply sort of thing. So if we were to multiply both sides by B, that would cancel off the divide by B on the right hand side and take B over to the right, which would become B multiplied by tan 40. But then you need to divide both sides by tan 40 to make the tan 40 on the right hand side, so then we can solve for B. So effectively what we're doing is cross multiplying them and swapping those two things around. So rearranging that will give us 15 divided by tan 40, which, referring to my working from the one I prepared earlier, should give us 17.88 meters to 2 decimal places. Okay, so we've got 2 examples there. One's an example of how you find the opposite, and that's by multiplying the tan of the angle by the adjacent. The other is when we're finding the adjacent, we have to take the length of the opposite and divide it by tangent of whatever the angle is. But if you try and remember it in terms of rearranging it, that way if you get confused, you'll be able to just, you know, rearrange it as you normally would and then come up with an answer from there. Okay, the third thing you need to be able to do is to find the value of an angle given the lengths of the opposite and the adjacent as well. Okay, so I'm gonna say this is 3 meters, I'm gonna say this is 5 meters, and I'm gonna write in theta here just to represent that that's the angle that I'm looking for. So again, we don't know the value of the angle yet. Sometimes they'll call it theta, sometimes they'll call it x or a or b, or they'll call it whatever the label for that particular like part of the shape is. So they could call that angle A, for example, but I'm going to call it theta for this example. Now I'm going to label my two sides. So 3 meters, that length is the opposite because it's opposite the angle. 5 meters is next to the angle, that's the adjacent. And again, the hypotenuse, and while we're not going to use it for this question, it's good to get into that habit. That's the longest side that's across from the right angle. Okay, now I'm going to write my ratio. Tan of the angle is opposite divided by adjacent. Cool, so that's steps 1 and 2 done. Now I'm going to fill in the information that I know from the question. So tan of the angle, we don't know what the angle is yet, so I'm going to leave that as theta, that 0 with a belt symbol. The length of the opposite is 3 meters. Length of the adjacent is 5 meters. Okay, so in, I suppose, like algebra with solving and that sort of thing, if you've got one unknown in an equation like this, you can always rearrange it to solve for that one unknown and find what that one thing is. Where this one is a little bit different is that because we're using this special ratio, we can't cancel off that tan function in a way by doing like a normal multiply or divide to get rid of it. What we do instead for this one is use the inverse function of tan. The reason that works is if I apply that inverse function to both sides, on the left hand side it'll cancel off and just leave us with the angle, but on the right hand side we'll just have that inverse tan function that we apply to, in this case, 3/5. So for this one we're going to say our angle is equal to inverse tan. And on your calculator, you get to this usually by hitting shift and then tan, or second function and then tan, or something like that. But it's that inverse tan function of the ratio of the opposite divided by the adjacent. So it's 3 divided by 5. It's not inverse tan of 3 and then dividing that answer by 5. It has to be the 3 divided by 5 ratio, or the opposite over adjacent ratio that you apply that inverse function to. Okay, so once you've done that, so say shift tan bracket 3 divided by 5 close bracket if you're using a calculator. It's not really if you're using your calculator, you will be using a calculator for this. That'll give you an answer of 30.9 degrees, and that's to 1 decimal place this time. Okay, so to recap, we've learned how to use the tangent ratio to find the length of a missing side, be it the opposite or the adjacent. Oh, wrong one. I'll just do more of an obvious highlight here, that's fine. And we've also used it to find the size of a missing angle as well, and that's by using the inverse function for the tan function. Okay, good one. So that's what you need for the second 2 lessons of week 1. So let us know if you need any help, and bye for now.